In today's video, we will be reviewing techniques to solve systems of linear equations. There are primarily two ways that we can solve linear systems of equations. We can solve them by substitution and by elimination. For substitution, we'd like to pick an equation and solve it in terms of one variable. For example, x equals something or y equals something. We want x or y by itself on one side of the equal sign. We can then substitute into the other equation and solve for the other variable, in this case, y. After that, we have a number, and we can plug y back into either equation to solve for x. For example, we consider this system. I notice that if I want to get x by itself in the first equation, all I need to do is add 2y to both sides. Now I have an equation that is solved in terms of x equals 2y plus 7. I can then substitute 2y plus 7 in for the x value in the second equation. This equation is now purely in terms of y. With a little bit of algebra, I can move numbers around, multiply things out, and eventually reach a y value of -5. I can plug -5 back into the first equation, and then solve for x, which gives -3. Thus, I have a solution for the system, an x and a y value, -3 and -5. When we consider elimination, we would like to add two entire equations in order to eliminate a variable. With one variable eliminated, we can solve for the remaining variable, and then plug it back in to solve for the first variable. In this example, just by adding the two equations, 2y and -2y will cancel out, leaving us with 4x equals 8. Dividing both sides by 4, we have x equals 2. We can then plug 2 in for x into the first equation, solve in terms of y, giving 2y equals -1, and then dividing both sides by 2, we have y equals -1/2. Here we have an equation where simply adding will not cancel a variable. The first thing to do is to multiply the top equation by -2. This way, when I add the two equations, my -2x and +2x will cancel each other, leaving just 7y equals -35. Dividing through, I have y equals -5, and I can plug this back into the first equation much in the same way as with substitution to find x equals -3. Once again, I have my solution of -3, -5. This is represented graphically as the point where the two lines intersect.